Today we start working with extreme values, and sometimes people get all worried about that word extrema or extreme values, but if you really just want to simplify, what we're talking about is max or min. We're really talking about maximums and minimums of a function and how we're going to use calculus to help us get there. All right? So, if we're looking at a function, and sometimes we know they do silly things. Let's say this is my crazy little function. Well, you can see there's several things going on. And there's a couple of maximums and there's a couple of minimums, right? There's a max here and a max here. And there's a minimum here and a minimum here. And now what I want you to notice is that on those two maximums, isn't there one of those that is bigger than the other? Yes. All right. So technically, if I was looking at an interval from, let's say, A to C, right here. Let's say it's going to stop right there, and it's going to stop right there. If I'm looking at that interval, on this interval A to C, this bigger maximum would be called the absolute max, and this smaller maximum would technically just be a local maximum. All right, so if there's two maximums within a certain interval, the bigger one is the absolute max. And it's the same thing for the minimums. Okay? Now, what I want you to already start thinking about with these maximums and minimums as it relates to calculus, and this is critical, and we'll spend more time on this in a minute. What is the derivative of a function? Derivative is slope of what? Slope of the tangent line, okay, at an instant, okay? Instantaneous rate of change, we can describe it in a lot of ways. Well, what is the value of the derivative at all of those maximums and minimums? Think about it. Tangent line, tangent line, tangent line, tangent line. Every one of them, okay, f prime is equal to 0. Every one of them, the value of the derivative is 0, or the slope of the tangent line is 0. And that's going to be a critical point for us. Now, real quickly, I just want to review something. Increasing, decreasing, and constant. Okay, if I'm talking about an increasing function or a decreasing function, well, if it's increasing, what do I know about the function values? Now, we're not talking about, I know that you're used to relating this to calculus, but let's just keep this simple. If I were to look at this function value, let's say that this was f of x2, okay, here's x2, and this is x1, so this would be f of x1. If I was relating those two function values, if it's increasing from left to right, what can I say about those two function values? Yeah, f of x2 is bigger. F of x2 is greater than f of x1 if it's increasing. Okay, this is increasing. Obviously, if it's decreasing, it's the exact opposite. If it's decreasing, then I would say that f of x2 is less than f of x1. We don't have to put all our labels on there. We're saying the same things. Here's x2, here's x1. And what would we say if it was constant about f of x2 and f of x1? They're equal to. Okay, so this is decreasing. And if it is constant, I'll just put it down here in the corner. If it's constant, which means I have a horizontal line, then f of x2 equals f of x1. All right, that's an important little review for us. Okay. Now, let's define, let's get a definition in here. Definition of absolute max and min. So there's a couple of prerequisites we have here, a couple of things we have to have. Number one, okay, f is defined. And we know what that means. That means that we don't have a bunch of crazy holes or discontinuities or things of that nature. All right? F is defined, and C is in the interval that we are talking about. All right? All right, here's our first statement. F of C is the max value of f in our set R. No, that shouldn't be for real numbers, sorry, just R. We're just talking about a set of numbers R. In R, if f of C is greater than or equal to f of x for every x in R. All right? And that makes sense. If it's the maximum value, it's the biggest one. All right? What would change on if I were to relate that to a minimum? Everything's the same, all the same, but f of c is less than or equal to all of the f of x if it is a minimum. All right? So point 1 is about a maximum. Point 2 is about a minimum. Okay? So let's consider a function, all right? And just kind of start working through this idea of some maximum values and the different ways these can look. Let's consider f of x equals 4 minus x squared. And we're going to look at it on 4 intervals. We're going to look at it on -2 to 1. Then we're going to look at it on, notice we're including both of them. Then we're going to go from -2 to 1, but we're not going to include -2. Then we're going to go from 1 to 2, and we're going to include 2, but we're not going to include 1. And then we're going to go from 1 to 2, and we're not going to include either of them. Okay? Now, we all know what this function looks like. Isn't it an upside-down parabola moved up 4? Yeah. All right? So, if I were to sketch this on part A, we know that it's going to come up to 4. And I also know if I were to set this thing equal to 0, 4 minus x squared equal to 0, I would get positive and negative 2 as zeros. So I know that this thing intersects at 2 and negative 2. But we're only concerned from negative 2 to 1. So here's the only part that I need to consider. Negative 2 to 1. That's the only part that I need to consider. And notice I colored in the circles because we have a closed interval. All right? So, if I'm looking at that situation in Part A, is there a maximum and a minimum? Well, there is a maximum. There is a maximum right here. This is a max. And is there a minimum? Yeah. Right here. Okay? So there is a maximum, a max at 0, 4, and a min at negative 2, 0. The reason I know that is because it meets our required definition. There is a value that is bigger than all the rest, and there is a value that is less than all the rest. Okay? Now, look at Part B. What changes with my graph in Part B? Negative 2 is not included, so it is an open circle. Very good. So there is only a maximum. Okay, there is only a max. The reason there is no minimum is because there's no end point down there. And I can always find another value closer and closer and closer to this negative 2. So there is no minimum. Okay? How about situation C, where we go from 1 to 2. One to 2. 2 is 1, 2, 3, 4. At 1, my value is 3, but it is an open circle. And then at 2, it's a closed circle. So that's what I have on situation C. So on this one, there is only a minimum. There is no maximum. Only a min, no max. And then on Part D, I'm going to have an open circle on both. So there's nothing. You lose. 1 to 2, I'm going to have open circle, open circle. Because I have two open circles, there's no maximum and there's no minimum. Okay? And remember, the reason for that is because I can always find another little point just a little bit closer. As soon as I use that open interval, there's no cutoff. Okay? And we are going to stop there for today.